Happy Dashera Shobhaji and good evening to everyone. Welcome to week 10 of 12 weeks remaining. Yeah, so we are approaching the end of this course. I have already started recording, so we don't have to worry about everyone else joining, and it's already 7. So let's begin today's session. Yeah, so we in initial weeks it was quite difficult to get hang of the programming and to understand the kind of questions what to expect and everything. So now we have gotten hang of everything, the kind of multiple choice questions, what type of questions are being asked and how to approach them, how to try to find the possible correct answer when we don't know the answer. So how to do most correct educated guess that we have seen in past 9 weeks. And now I have noticed that it takes us less time to complete the quiz type assignment, and even the programming type assignments. We have started working out the algorithm first, and then we move on to the code. So that approach is also really efficient, where any logical doubts or how to tackle a particular programming problem, those doubts are generally clarified at the algorithm level, and then we translate that algorithm into code. So so that is also working out really well. So we'll keep the same approach, and we'll begin week 10 of this thing. So you all know about me. I'm Indrayani, and I'm a PhD research scholar from IIT Bombay, and I conduct this tutorial sessions along with 3 other TAs. So and we upload screen recording on YouTube, and the links are shared to you all via the Excel sheet, which is uploaded on the Swam platform. Yeah. So let us move back to let us move to assignment quiz, right? Week 10, the assignment. So I found this more productive and less time consuming, where I'm directly printing the assignment questions into PDF rather than copying everything into a separate PPT and then using that PPT for explanation. There's enough space here for me to annotate this thing. So I'll be saving time and using this for rest of the weeks. Yeah, so this is very simple question for week 10. So week 10 questions I personally found were very simple compared to previous weeks. They were very straightforward. So I'm hoping that we'll finish today's session in actually 1 hour. Like we are ideally supposed to finish it in 1 hour, but we take 1.5 hours because the time is not important. The understanding everything is more important. Yeah, so today I'm hoping that we'll finish everything in 1 hour. Yeah, so let's see how much time we take to do it. Yeah, so first question is pretty straightforward. Here we are given the string hello everyone, and the next statement is print s dot lower. So for that we should know what this s dot lower does. Yeah, what this particular s dot lower does. So it converts all the uppercase letters into lowercase. Yeah, so now when you see, we are passing this s as a argument. So this string, all the uppercase letters here will be converted into lowercase, right? So what will be the output? Smaller h, and rest of the rest of the lowercase letters, they will remain the lowercase only. Yeah, so they will be printed as it is. Hello everyone. So this will be the output, which is here in the this option, hello everyone, option D. Yeah, so it will not join or concatenate, or it will not reverse the uppercase to lowercase and lowercase to uppercase, but any string dot lower, that function will only convert the uppercase letters to lowercase letters. So it was easy to understand that way. Yeah, so question 2 was what this particular statement will return. So type function, it returns the data type of argument. Yeah, so in this case the argument is number 9. So what will be the data type? So this is the question. You can type your answers in chat box, and we are very few of us, so you can unmute and answer also. What will be the output of this? What do you think will be output of type 9? Okay, so I've got two answers as integer, so that's correct. By default, 9 is a number which is of integer type, so it will return the integer number. Yeah. So when it is a not the non-decimal number, the complete number, then unless and until it is decimal number, default data type for number type is integer. If it would have been 9.8, then default data type would have been float. Yeah, but not for complete whole number of 9. Yeah, for whole number, data type would be integer. Yeah. So what will be the output of this particular code? Yeah. So in first statement, it is the collection of the letters and some empty spaces, right? So this is the space, and this is here, it is space. Yeah, and rest of it are all letters. Now print, there is a full stop dot join, and we are passing this array here. Yeah, array A. So all the elements of array. So all the elements of array will be joined using this full stop. Yeah, so it will be empty space, empty space dot full stop, index 1 h dot full stop, index 3, this is index 0, right? Space is index 0, so space will come first, then h dot e dot l dot space, then dot, yeah, then again l will come, dot o. So this will be the output. Yeah, so spaces I have underlined, but in your output it will not be underlined, right? So we have to see string starting with full stop h e l empty space, so here is empty space, and o. So this will be the correct answer. So Shobha ji, was this for, I think your answer must be for this question. So answer will not be option B, but it will be option C. Yeah, you got it. Okay, fine. So let's move on. Yeah. So now next question is, which of the code snippet represent replacing all vowels with hyphen? Yeah, replacing all. Yes, Birendra ji, option C is the correct answer. Yeah. So moving on to next question, question 4. Which of the code snippet will represent replacing all vowels with hyphen in the string when the string name is S? Yeah. So keep in mind, we have to look for the code because the code is not here on this page. So we have to look for the code which will replace all the vowels with underline. So we have seen this type of questions where we are replacing the vowels, where we compare every letter in the string with vowels. We store all the vowels in another separate string, and that's how we approach it. Yeah. So instead what we can do is we can use the replace function of which is there inbuilt for the string class. Yeah. So we are using that same replace function, and we will replace every vowel which is part of this particular string S. So let us list down all the vowels: A, E, I, O and U, right? A, E, I, O, U. So we will check for all these vowels whether they are part of the replace function. Yeah. So S is the string, A, E, I. So I is twice. Do we need to like here it is twice, but do we really need to execute any any vowel twice with the replace? Will replace function will replace only first occurrence? It is not like that. Okay, so the replace function will replace all the letters I in the first go only, this go only. So this will not find any I. So this is the redundant code. Yeah. So this is not the answer. Now in the second option, option B, there is a syntax error. this particular statement, like replace and first hyphen and then letter, yeah, this means that we are replacing hyphen with letter, replacing with a, we are replacing this with this. So this is the wrong syntax, so this cannot be the answer. Moving on to option C and D. So option C is again a syntax error. Here we are replacing hyphen with vowels, which is wrong, yeah. And option D, let's check, A, E, I, O, U. So this is, and we are replacing with vowel. So here it means we are replacing the vowels, that is A, E, I, O, U, with hyphen, yeah. So the correct answer is option D. Yeah, it was very simple, like fairly simple. We just had to check the syntax and check whether all the vowels are getting covered, yeah? And when we replace the same letter using two different statements, it makes the code redundant. It will not make it better, yeah. Okay, yeah, so our yeah, so this is the correct answer, which we have already ticked, option D. Yeah, so moving on to question 5, what will be the output of following slicing? Yeah, so slicing, I think I had explained in one of the assignments. Yeah, so this is the what does this slicing do is, when we are mentioning indices separated by colon, that means we are slicing or we are cutting that particular string. So here 3 is the starting index of smaller or cut string, yeah, starting index, and this is the end index, yeah. So what we are doing is, original index is S, yeah, so S here is the original string, not original index, sorry, my bad, original string. So we will first write down, let us write down all the indices on the top of original string, yeah. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11, 12. So this is one string, so we have to assign one separate index to the space which is here, yeah. So this first space between the and joy has the index 3, and space between joy and of has index 9, space between of and capital C has index 10, yeah. 12, 13, 14, 15, 16, 17, 18, 19, yeah. So these are the indices. So now we are slicing from index 3 to index 12, yeah. So let us see, where is index 3? So space is index 3 and index 12 is O, yeah. So this will be the output of this slicing. So it will be joy of CO, yeah, joy of CO, yeah. So this will be the correct answer, yeah, because we have to consider the space also. So if you carefully see, there is a space between this inverted commas and capital J, yeah. So both of them are same output, but here there is no space, and we have to consider space also. So option D is the correct answer. This was also very simple. So now next question asked us to check the code. What does following code represent, yeah? So let us have a look at the code. So we have the string and we have the list of vowels, all capital and small, yeah. So all the vowels are listed here, yeah. Now we are checking I in the range of length of S. So that means we are checking the index of string S. So if S dot index of S of I, which element? Ith element, because this is not the element, I here is not the element, but No, here end index will not be -1, Sudhaji. It will, I think it should go till the last index, because that is what. Just a minute, let me think. Oh yes, oh yes, oh yes, yes. So it will go till 11. Sorry. Yeah. Thanks for pointing it out. Yeah. 12. It will go till 11. Yeah. So O will not be there. You're right. It will be 1 minus. Yes. Yes. Sudhaji and Rotu Akhil, both of you are correct. Yeah. There was mistake on my part. Slicing may it starts with the 0, so we consider the first index as the starting index. So it will start with the space. Yeah. But end at the 11th index. Yeah. So it will not be the correct answer. Option D will not be the correct answer. Option B will be the correct answer. And for the same reason, there is no space, so option A will not be the even though both are same, the option A will not be the this thing. Yeah. Okay, thanks for pointing out. Thank you so much. Yeah. Okay. Yeah. So here in this next question, we are checking if all the elements is mod 2, it means it is divisible by 2. The remainder should be 0. So mod 2 equal to 0. This checks if the remainder of the division is 0. So in S of I, mod 2, that means the index of that particular element is even or odd. So this is condition for even. Yeah. So if that index is even, then we are printing I. And we are checking if S of I, that means that particular element at index S, is part of this A, which is the list of vowels, right? These are the list of vowels. So if this element is part of A, then we are replacing that element with hyphen. Yeah, replacing element with hyphen. Not hyphen, underscore. Yeah, replacing that element with the underscore. So that means we are replacing all the vowels at the even index with the underscore. Yeah. So replacing all the vowels at even index with underscore, that is option C. Yeah. So yes, option C is the correct answer. Yeah. So is this clear, or any doubts? Shall we move on? Yeah. Okay. Thank you. Let's move on to question 7. So we are importing another library called NumPy. Then we are declaring a 2D array or a matrix, a matrix. Yeah. So this is first row and this is second row. So this is what this means in our normal mathematical language. So now we are printing np.sum, sum of whom b.axis is equal to 0, of the elements of this matrix B with the axis 1. Yeah, with the axis 1. So now these are the parameters of 2D array or matrix. Yeah, when we say axis is equal to 0, we are referring to row, and when we say axis is equal to 1, we are referring to columns. Yeah, because we go like this now, this element like we are representing every row as an array. Yeah, it's an array 1 and array 2. So now when we want to show it as a matrix, it will be another matrix containing array 1 as one element and array 2 as another element, right? So this is the index 0, index 1 and so on. Yeah. So when we say index 0, we means number of rows. Yeah, that particular row, or all the rows are index, basically all the rows are index 0 and all the columns are index 1. Yeah. So when we are adding all the elements of index 1, that means we are adding column wise number. So 1 plus 3 and is it, yes, 4 comma yeah, so it should be, I think I'm making some mistake again. Is it 3? Okay, yeah. So it is like 4 comma 6. Yeah, 4 comma 6. So option should be option A. But I think it should be other way around, right? Where did it go? 7, yeah. Am I correct? Like axis 0 is row and axis 1 is column, or I switched again? Like
The answer should be 3 and 7, ma'am.
yeah,
Ma'am,
yeah.
it
So
will
I think
add.
I
Ma'am,
think
it will add, ma'am. I guess that up. What do they call them? A column.
yeah. So
So
that's what. Yeah. That's why I mixed
I will
up this.
switch.
Like axis 0 is this. Yeah, I mixed up here. Like yeah. Yeah, so when we say axis 1, we'll add the this thing. Yeah, sorry, row wise addition. So one row and second row, so it should be 3 and 7, right? Yeah, I'm making a lot of mistakes today. Yeah, 3 comma 7. I don't know why I'm making a lot of mistakes today. Yeah. So I'll repeat once again. Sorry for confusing all of you. So when axis is 0, we consider the columns. Yeah. So generally, yeah. So actually, I left this explanation midway. If I would have continued, I would have caught my mistake. Yeah. So generally, when we represent any tabular data or 2D data, yeah, so there are one index for row and one index for column, one index for row and one index for column. So when we have to, like, when we want to address this particular element, what we will do is we will first say which column it belongs to. Like this is 0th column, this is first column, so we will first put the column number, and then we will put the row number, 0th row, first row. Yeah, so 1 comma 1. So we always, when we want to in two dimensional representation, so here it is a matrix, right? It is a two dimensional 2D array, yeah, or matrix. So how do we address the, how do we specify which element we want to address? Yeah, so that way we always say column name or column number or column index and specified by row number or row name or row index. That is how we always represent a 2D a data item from a 2D data type. Yeah, so here when we are saying we have when we have 1, 2, 3 and 4, so now we want to do, so this is 0th position and this is the first position, right? No, I'm making the mistake again. Let's not go there. Yeah, so when I'm saying axis is equal to 1, that means we are adding the columns, column wise addition. Oh, making mistake again. Yeah, 1, 2 and 3, 4. Yeah, so we are saying, so this is 0 and this is 1. So when we are saying we are adding axis 1, so that means we need to do row wise addition, 1 plus 2 and 3 plus 4, which is 3 and 7. Yeah, so this is how you can remember. Like first we will specify column number, so when axis is equal to 0, we are referring to column. Then we will specify the row number, so when axis is equal to 1, we are referring to rows. So when we want to add elements, all the elements with axis 1, yeah, this is what this is doing, np.sum is doing. It is adding all the elements from this 2D array B with the axis 1. So axis 1 means row number. So all the row elements, row wise addition we will do. So 1 plus 2, 3 and 3 plus 4, 7. Yeah, 1 plus 2 and 3 plus 4. So this addition would be 3 comma 7. This will be for row 1 and this will be for row 2. Am I clear now? Birendra ji, now is it clear?
It is clear now.
Okay, thank you Aditya for confirmation. I'm sorry for confusing. Okay. Yeah. How to transpose this, which is the correct code for transposing any matrix. Yeah. So this particular question has two correct answers. Yeah. So in first statement of every option, we are declaring a 2D array with first row as 1 comma 2 and second row as 3 comma 4. Yeah. So there is all the first row is identical in all the 4 options. So that means we have to concentrate on the second row. Yeah. Second row may let us check once. So what are the variations? Variation is with the bracket which goes for parameter after the function. Yeah. So first option says b dot t and there are the empty braces, like empty parameters. Then there is b dot transpose with empty parameter. Then there is b dot t and then there is b dot transpose. Okay, so this is the matter of remembering the syntax of transpose function. Yeah. So when we are using the complete function transpose spelled completely, then we have to specify the empty brackets. Even though we are doing b dot transpose, but still we have to specify the empty brackets. So option B is the correct answer and another answer is b dot t. Yeah. So it is very straightforward syntax type of question. Yeah. Yeah. So moving on to next question. So this is also very simple. Our lossy and lossless compressions are the same. That's the question. So I think it can be answered even if you have not watched this week's videos. In this week's video, this concept has been covered with the compressions and lossy compressions, lossless compressions. But even though you haven't watched, this statement is like you just need some common sense to answer this. Will the lossy and lossless be same, the compressions? It will not be, so the statement is false. Yeah. So what happens in lossy compressions is we will lose some data points and we will lose some data, and lossless compressions may will try to preserve as much data as possible. So lossy may we end up losing some of the crucial points to build the uncompressed data, but in lossless we will not lose all the crucial data points to build up the complete document or complete data set. Yeah. Yeah. So coming to question 10, what is the shape of the following numpy array? Yeah, so now before I get confused, let me write down how to give the 2D this thing. Yeah. So column number comma row number. Yeah, this is how we represent a 2D data type element. Yeah, 2D data type element. Yeah. So now this is the metric we have. First row is 1 2 3, second row is 4 5 6. So in order to have the shape, that means the total number of columns and rows, so we will calculate how many columns are there. So there are 3 columns and 2 rows. Yeah. So that means the shape of numpy.array, this will return column number 3 comma 2. Yeah. So this should be the correct answer. God, what is happening? We're making mistakes again.
Ma'am?
Wasn't this supposed to be 3 comma 2? Yeah.
I think that should be 2 by 3.
2 by 3 na? Haan.
Yes, ma'am.
Okay, yeah. I will not spend much time. I'm getting confused in the row index and column index. Yeah, so the answer for that was 2 comma 3. Yeah. So I don't know what is wrong with me today. I'm getting confused in row index and column index. Yeah. So now let's shift quickly to programming assignment before I confuse you more. Yeah. Yeah. So the first question says we have to given the list L and write a program to make new list to fix the indexes of the numbers in the list L. It's as the same value in the new list. Okay. So this is confusing. Let us go to the explanation to understand what is expected out of this question. Yeah. So this is the input array 1, 5 and 6. So what the question means is the value of element should be same as that of its index. Yeah, should be same as that of its index. Yeah, so 1 should go to index 1 and 5 should go to index 5, 6 should go to index 6. But then what about other elements? They should be filled with 0. Yeah, so the output should be 1 0 1. Then so this is the 0th element 1 2 3 4 5 and 6. Yeah, so there are no 2 3 4 in the list, so that will be 0 0 0 and then 5 and 6. Yeah, so this is what we are expected to do. So what we will do is how do we tackle this particular thing? Yeah, so what should be the first step? First step should be identify the, yeah, let me put down first. So identify the largest element in the list. In the list L, which is the input list. Yeah, so when we have the largest element, then we can declare and initialize an array or list with length is equal to that largest number from list L. Yeah, so let us try to do this with this example 1 comma 5 comma 6. So which is the largest element of 1 comma 5 comma 6? 6. So that means we need to declare another this thing, yeah, another array. Yeah, so another array with 6 elements. Yes, Rotu, you are right. We should have the index of the last element should be length plus 1. Yeah, yeah, another array with the 6 elements. Yeah, so 0 0 0 0 0 0 and 0. Yeah, we need to add 1 to it. Because 6 will give us just the 6 element with index till 5. So if we want last element to have index 6, we need to add 1 to it. Yeah, largest number plus 1. Okay, yeah, so these are the 7 elements 1 2 3 4 5 6 7. So now in step 3, what we can do is in for loop we have to check if this element is equal to this element from the list L. Yeah, so let us call this something else, say A. Yeah, sirf A. So let us see if A of I, so we need to consider index here, right? So we will A of I is equal to, sorry, not A of I, we need to see L of I. L of I is equal to I. That means the element from list L should be equal to index of this, right? So we will replace that L of so A of I will be replaced with I. Okay, so so have you gotten this? Okay, so I made mistake. So there should be 2 loops. One for loop for traversing through the elements of list L, and other for loop for traversing through the list of elements A here. Yeah, so here if for this I, if it is J, then L of J is equal to I, then A of I is equal to A. A of I is equal to I. So that means we are setting the value of this element with the index of that element. Yeah, and we are checking if this element is equal to index of that element. So have you gotten how there will be two for loops? One for loop will traverse through this list L, which is 1 5 6 in this case. Yeah, so let us try to execute this, yeah, outer for loop. So if j is equal to 0, then L of j is equal to 1. Yeah, so that means in first for this inner for loop, the first iteration, it will not do anything because this condition will be false. Yeah, so but for I is equal to 1, this second iteration of this inner for loop, yeah, I, where we are considering I, for I is equal to 1, L of j is equal to 1, which is I value. I is equal to 1 and L of j is equal to 1. So if condition is true, and then A of I, which is 1 now, for this iteration I is 1. So I is 1 getting replaced by 1. So after this first element, j is equal to 1, when j is equal to 1 gets over, we have A as 0 1 0 0 0 0 0. 1 2 3, 1 extra 0 I gave. 4 5. Huh. Yeah. And similarly for the next outer for loop, where j will become so here is j will become 1. So for out, then we are again coming to inner for loop. We are comparing j of 1 is 5. So we are comparing all this L of j is equal to I. So at 5, this condition will be true at I is equal to 5. Then we will replace a fifth index element with 5 and so on. So have you understood this algorithm, how we will do it? Shall we check the code once? Okay, great. I'm getting what's up. Let us reconnect. Oh god. Okay, nice. Hopefully we should be getting in soon. Yeah, week 10. Let's open week 10 notebook. Yeah, so this is what I have done. I have first, this is the input list, then I'm checking which is the largest number of this particular input list L. Then I am declaring the empty matrix of length of maximum number of n plus 1. Yeah, largest number plus 1. So we have seen why that plus 1 is required in the algorithm section. And now this square bracket 0 multiplied by m plus 1 means we are adding those many zeros in that list L1. So largest element was 1 5 6 mein, the largest element was 6. So we are adding, we are creating L1 with 7 zeros is what this line means. Yeah? So for all the elements in the list L, we are checking if we are setting L1 of I is equal to I, or otherwise we can use the two for loops for accessing all the index of the original list input list L, and inside that we can have another for loop for all the index of this index list L1. Yeah, or otherwise for every element we can do this. For every element L, we are replacing that index in L1 with that element. Yeah, so we are pushing that or putting that element from input list at the index position, respective index position. And in this we are just printing all the elements here. Yeah, printing the final output. So let us try. It is still allocating the resources. Okay, so any doubts in this code? So in the algorithm, I just discussed how we can, how we can use the index approach also. Yeah, 0, 1, 0, 0, 5, 6.
Excuse me, ma'am.
Yes. Yeah.
And why have you used range function and the last to print L1, ma'am? We can also do it
Directly also you can print the same thing. Na? For I in L, you can use I in L1. And then you can just print all the i's. Yeah, print I. Yeah, instead of that. Yeah. So
no, ma'am, we can do print L1 also simply, ma'am.
Simply print L1 also we can do. Yeah, that is also that's also a valid approach. So that was the whole point in the algorithm. I think print of L, yeah, that will also give all the elements in that list. Yes, print L will also give, but we want it in the one line separated by space, all those things. So to avoid any because in the portal you get checked for every output. No, you will get all the elements when you do print L or print L1 also, but then the format of that showing of that output will be different. So to avoid that, I have gone the old school way while printing, because we want every element in one line separated by one space and so on. So to avoid any confusion there, because otherwise the output is not considered valid and your code will be considered buggy. Yeah, so now let us see what is the second question. Yeah? So what the second question says, Ram shifted to a new place recently and there are multiple schools near his locality. Now given the coordinates of Ram are x, y, so Ram stays at the coordinate x comma y, capital X comma capital Y. So let us see, these are the house coordinates, and schools near his locality are in the nested list. Now find the closest school. Now print multiple coordinates multiple coordinates in respective order if there exists multiple school closest to him. So that means if two schools are equidistant from Ram's home, then they should be considered. Okay, so if the distance value is same, like one school is 5 kilometer, other school is also 5 kilometer, so we should consider all those coordinates and we should give that in the we should print that in our output. Yeah, so write a function closest school that accepts x comma y comma L, where x and y are coordinates of Ram's house and L contains the coordinate of different school. Yeah, so this is the nested list, which will have the list of coordinates. Yeah, okay, great. So here they have given the distance formula. We have to use this formula to calculate the distance. Okay. So now these are the inputs. So number of schools and those many coordinates we have to give as input, and xy, the first input would be the house coordinate of Ram. Okay, and okay. And we are to print all the closest this thing. So that means when we take input x1 comma y1, x2 comma y2, x3 comma y3, and so on. Yeah, so on. This will be part of list L. Now we have to calculate this distance compared to x comma y coordinates. Yeah, and we need to see which has the minimum value. Yeah, so what we will do is we will in for loop for nested list L. So x1 comma y1, this we need to access. Yeah, so it will be L of 0, right? So I 0 1 2 3. Yeah, so I comma I of this L, nested L. Yeah, this will be x1 y1. So we need to using that formula. So what was the formula? X2 minus x1. So in this case, this will be x1 minus x the square plus y1 minus y the square, okay, and square root of this. So this will be the distance. Yeah, so we'll calculate the distance by using formula. So now we have calculated this distance. Now we need to compare if this distance is minimum distance. So how will we so we need to compare it with some random value first. So we'll initialize this minimum distance, say mean d, to some random value, say any random value, say 1000 or 10,000 maybe. So if this dist is less than minimum distance, then we will replace the two values, no? So now new mean d will be the distance. Yeah, so or if distance is equal to mean d, we have to consider this also, na? Yeah, this multiple coordinates in respect order. If there exist multiple school closest to him, yeah, so we have to consider if more than one school is at equal distance. Yeah, so this is how we will compare it. Then we will append it. Okay, yeah, so we have done this. Apart from that, we have to maintain a list of coordinates, no? So some say a, so a will be x1 comma y1, no? Then we will append this a, because we have to add this at the end, whatever the coordinates like x1 y1, to this list, a dot append. So we need to do that. So have you understood how we are doing it? So firstly, for every element in this nested list L, we have to calculate its distance from Ram's house, which is at x comma y. Yeah, so what we are doing is, for every element of L of I, so for every index of elements of L, we are assigning that to x1 y1. So this is happening in the for loop. So every time this x1 y1 will be, for the first iteration it will be x1 y1. For I is equal to 0, it will be x1 y1. For I is equal to 1, it will be x2 y2. For I is equal to 2, it will be x3 y3, and so on. So this one thing is clear. So we are assigning these values, then we are calculating the distance using this particular formula which is mentioned. Yeah, then we have to check, we have to see if that is minimum value. So we don't know what is the minimum distance value, so we are assigned minimum distance some random value. Say the first run in the first coordinate, like x1 comma y1, that will get assigned to this, that value will get assigned to this minimum distance. Yeah, but then in the second run, if it comes, then that should get overridden, right? So let us do one thing. We should also declare it to 0 0 first. Yeah, for every time distance becomes less than minimum distance, then every time in that for loop we are declaring another array to store the coordinates. Yeah, so we are overwriting that existing thing. Okay, so this is one we should keep in mind, because this is random comparison. We are assigned a random value to minimum distance, because we don't know what is the value of minimum distance. So what we will do is, we will calculate all the, so the other approach will be to calculate the distances and store them at x1 y1 x2 y2, like that, some distance list called distance, and all the distances like d1 comma d2 comma d3 comma d4, and then find the minimum value of this array, find the minimum value in this distance list. Yeah, minimum of dist value, then index of that. So that will give you what element it was, 1 2 3 4 0 1 2 3 4. So when you get the index of that element, index of that distance, you know what corresponding coordinates to get for. Yeah, but then in this approach, there is one problem. If there are two schools in the same distance, then we might not get the proper output using this approach. So that's why we are getting the longer route. We are calculating this distance for every number inside the for loop, and when that distance is less than the minimum distance, which is the random. So now after the first run, that minimum distance, since it is some random large value, so at the first run, whatever the output will become, that will become the whatever output will come, that will become the minimum distance. Then we are again creating an array to store the coordinates of this x1 y1, which was L of I and I. Yeah, so those elements. Yeah, so I know it is little confusing right now, but let us check the code. At that time it will be little clear. Yeah, so I'm not going to ask whether all of you understood the algorithm, because I know the algorithm was a bit confusing. Yeah, so let us try to understand through the code. Okay, I explained you why I did not create a separate list of all the distances and then sorted that and gotten the minimum value, and then backtracked it to corresponding indices. Yeah, so that is one way. But then when there are two matching values, then we have to think about a longer route. Yeah, so this gives the output even for the matching values. Yeah, so how to take that route. Yeah, so this is the function closest school. Yeah, so minimum distance is some random large value. There is another list called distance, which will store all the distances of that particular point. Yeah, so now for every element in this nested list L, so L is the list of all the school coordinates like x1 y1 x2 y2 and so on. So for all these, we are storing that as x1 and y1. Yeah, all the element, that particular element, the first element, the second element. So this is how we are storing the nested list element, and we are addressing those elements as x1 y1. Then now this d is, we are calculating the distance using the formula. So now when that distance d is less than the minimum distance, then we are storing the indices in the empty array, the index array. So this distance stores the, so let me mention here. Yeah, this distance, it stores the coordinates. Yeah, so this distance matrix stores the coordinates. So now we are appending the indices of that particular school, and we are making that distance d as minimum distance. Now this else if part is just checking if there are matching values of minimum distance. If there are matching, then we are appending the coordinates in the distance list. Yeah, and this is for loop is for printing. For every element we are printing all the coordinates. Okay, so this is the input statement. Yeah, this x comma y is the input statement. I think it will give error. Yeah, so this is the input statement we are asking. So n is total number of schools in the neighborhood. Then for loop mein we are asking, we are taking input for nested list, yeah, the coordinates of the school, and then we are calling all the elements. Yeah, so here we are just storing all the x and y coordinate in small l, and then we are appending that small l to a capital L, which is nested list, that is 2D array. Yeah, so we are every row we are storing in the capital L, and this small l is list of split, is it is converting x1 y1 input in the single line by user as the rows. It's the two rows. Okay, so let us run and see. So this is the Ram's house coordinate. So let us see 5 comma 6. Yeah. So total, let us try just try for the two schools first to understand how it is going. So let us say 10 comma 13. Return. This is the first coordinates of first school. Then second school coordinate, let us say 14 comma randomly say 5. Yeah, so out of these, which school is closer? So 10 comma 12 wala school is closer to Ram's house. That is what this output is telling us. I know this program was little difficult to understand, and the algorithm was also difficult to comprehend. So let me know if there are any questions in the algorithm or in the code. Yeah, I have tried to explain why I have not used the alternate route and why this particular route. But if you want, you can try the alternate route which I have explained. Yeah. So I'll keep this code here for a couple of minutes. You go through the code, understand the comments, and if there are any doubts, let me know. So okay, all of you got how I'm using input statement inside for loop. So first, in first line we entered 10 space 12, which are coordinates of first school, and in the second line we entered 14 space 5, which are coordinate of the second school. But this 10 and 12 are considered as list elements, two list elements, 10 comma 12, and that list we are adding it, or we are appending it to nested list of capital L. Yeah? So this is how this input for loop is working. So this for loop here, what we are doing is we are considering elements of this nested list capital L. Yeah, so I is the element. Yeah. So for this input, this 10 and 12 is the 0th and first element of this particular row. Then in the second loop, that list will be considered as a second element, no? So that second element will be 14 comma 5. Yeah, so this is what we have done here, 0th and first element, because there are two elements in the row, 0th element and first element, and this for I in L will return us the row, every row. So this is how we are doing I of 0 index and I for 1 index. That element we are storing is as x1 comma y1. Yeah, here x1 comma y1. Then we are calculating the distance using formula. Then we are comparing if this distance is less than minimum distance. Then we have declared an empty array to override, because every time we are calculating the distance and every time we are comparing it with minimum distance, so we want only those coordinates there, x and y, which are at the minimum distance. Yeah, so that's why for every for loop this new list is declared to store the coordinates of the school. Yeah, and then we are appending that element. So now that element matlab that row, those x and y coordinates which are I for this from this for loop here, because we are considering element, not the index. Yeah, so that we are appending, and we are updating the minimum distance value with this calculated distance d here in this row. Yeah, this d value we are updating that as minimum distance. But what if this distance is equal to minimum distance from previous run? Then what we are doing? Then we are just appending without declaring any new distance list. We are appending the current coordinates in the existing distance list. Clear? I will again give you some couple of minutes to ask doubts if any. Instead of list, we could have done this using dictionaries also. Like in dictionaries, the x coordinate, y coordinate of the school followed by its distance. Then we would have considered only the distance element after the x and y coordinate. If that is minimum, then you print the x1 y1 or x and y. Oh, that was another approach, but we needed to use the nested list here. Okay, so I am assuming that there are no doubts, so we'll move on to the last question. Yeah, okay, so yeah, given integer n, print is this the correct this thing, or did I forget to update? Yeah, I forgot to update the question. This was the last week's. Yeah, so let us see here. So given the string s, write a program to convert uppercase letters into lowercase and lowercase letters into uppercase letters. Yeah, so this is what we are asked to do. So this is fairly simple, because in the questions also we have seen how we convert uppercase to lowercase and lowercase to uppercase, right? We have seen many in assignment quiz questions also, so dot upper and dot lower, so all those things we have done. So this should be easy to understand code. So we are storing all the upper cases in the here in the string here called upper, and all the lowercase letters here in the lower. So this is the input string s, and we have declared an empty string to store all the store our answer, where we are converting all the uppercase letters into lowercase and lowercase into uppercase. Yeah, so for every string I, for every element in the string I, we have to check if that I is uppercase. If it is uppercase, then we are checking its index from this uppercase ASCII codes. Now we are converting that into lowercase. Yeah. Now why we are not using dot upper and dot lower function? Because if we use dot upper, it will convert only the lowercase letter into uppercase and not the uppercase letter into lowercase. So we want to get the two actions together. So that's why we have to check for every element for its case, whether it is uppercase or lowercase. Yeah. So for uppercase, we have to take the index and then take the that matching index element from the lowercase. Yeah, because this ASCII dot uppercase and ASCII dot lowercase, these functions, they will store all the elements in the alphabetical order, all the ASCII codes in the alphabetical order from A to Z. So this will store the ASCII codes for or the uppercase letters, and this will store all the ASCII codes for lowercase letters. Yeah. So now we are checking, we are getting that index, and the same index belonging to lower we are getting from the lower, and we are appending it because it is string. Yeah, so because it is string, so we can use this answer is equal to answer plus lower from the lower this list, that this index element of the element belonging to that particular index. Yeah. Yeah. So similarly for lower, we need to see if that particular element belongs to the lower case. If it belongs, then we will get the index of that element, and we will retrieve the element of that index from the upper string. Yeah, this is how we are doing it. Or otherwise, what happens is, if there is a special character in the list, then we are appending that element as it is. Yeah, we are adding that element as it is. So is this code simple to understand? So I have not used dot upper and dot lower codes, because that will not convert the vice versa, the uppercase to lowercase and lowercase to uppercase. We have to do both the actions together at one go. That's why I have not used dot upper and dot lower functions. Instead, I have stored all the uppercase elements and all the lowercase elements ka ASCII key into this, and now I am just getting the index from this upper wala ye or iska index, and then I'm matching that index and getting the lowercase, and if it is lowercase, then uppercase element. If it is uppercase, then from the lowercase element wala string. Yes, Shobhaji, we can use swap case also. Yes, we can use swap case. Yes. Yeah, that will be easier. Yeah. It did not occur to me. That's why I took the long cut long route, Yeah, we could use swap case. That would be what, 4-line code, yeah. Yeah, 1-line code. Yes, absolutely. So total 4 lines, 1 to accept the input, and 1 to convert it, and then the output. Yes, swap case. Somehow swap case did not occur to me. I just took the longer route. Yeah. So there's another function called swap case, which will do this toggling of uppercase lowercase. Yeah. So try looking for swap case function. Google will give you the index as swap case, where argument you have to put as the input string s, and just store that output in the answer, and then print the answer thing. So yeah, this, you don't have to take this long route. It'll be one simple statement. Yeah. Yeah, so let us get the mix of something. The happy dance, and let us give some special character. Yeah. Yeah. So now upper to lower, lower to upper. Yeah, so I think this was easy to understand, and Shobhaji also told us simple way to do using swap case. One single statement so instead of all these for loops and checking for the conditions and then swapping it, instead of that, we can use the swap case function also. But if you want to take the longer route, hello, am I audible? Somehow it shows me that I got disconnected. Yeah, now I think I'm back. Hello, am I audible?
Yes.
Okay, great. So we are at the end of the session. Nothing more to discuss from my side. If you have any doubts, you can please ask. Okay, so I assume there are no doubts, because I'm getting thank you and yes in the chat boxes. So yeah, so if there are no doubts, then we'll close today's session, and we'll meet next week. Okay, thank you all for joining. I'll be sharing the PDFs and the recording and everything. Sure, sure. Yeah, you can ask me in the next week's session also, Shobhaji, if there are any doubts. Yeah. We'll be uploading this annotated PDFs and recording also on YouTube, and those links will be shared through the Swayam portal. Okay, then I am closing this session. Thank you all for joining. We'll meet next week.